Welcome to the Meltzone Podcast from January 6th, 2021. This is episode 41, and I'm Tom.
And I'm Stefan. And on today's podcast episode, we are going to talk about the current status on Corona for us and for the world, I guess. Different uplifting news or updates from our side. We had our belt printers for a couple of weeks now and just talk a bit how it's going with them, what issues we have and what we could potentially do with them. Then on the news topics, again, 2 times faster 3D printing, a service that is promoted on Kickstarter that basically shapes the accelerations of your printer to make it faster. Also, basically on the same topic, we just briefly talk about how would we design the fastest 3D printer we could think of for impatient persons like myself.
Yeah, and if you want something that's more plug and play, I guess there are 2 products or concepts that are being put into development for really fast resin printing. One of them is the rotational reverse CT scan approach, and the other one is I explain it in the episode. Just stick along. It's too much to explain right now, but it is a really nice, interesting concept that unfortunately is already patented. So we go on a bit of a patent rant there. Stick around for that. Then for some more stuff, there are quick change platforms that are pushing into the market. There are several ones that you can choose from right now, and we take a look at the WhamBam Mutant system that I have for review right now. And lastly, we talk about, whether doing reviews and the YouTube stuff we're doing traditionally is even still worth it. You ready?
All of that Corona hair.
Yeah. It's getting to a point where it's becoming unmanageable. So
I also definitely need to go to a hairdresser. So I think the last time when I went was 2 weeks before my daughter was born, so that was half a year ago. Yeah. They don't look as long on my head as they really are when they're, for example, wet. That's the advantage, but it's starting to get a bit crazy.
Curly hair is good in that regard. I mean, for me, it's just like, okay, this is unbearable. It's just in my face everywhere. Fun fact: I used to wear my hair almost down to my shoulders. Many years ago, dyed it like white once or white blonde once. Those were fun times. Still some photos from that.
If you would dye them black now, you could do like a not a goth style. Oh man, I'm already forgettable.
Okay. For the time being, I'm just glad that I still have as much hair as I do. I'm heading towards 30, and I know people who have started losing hair at 25. So I'm glad that I still have as much as I do.
Yeah. No need in start polishing your bald head at the moment.
Nah, but that's one thing I can guarantee. Like as soon as like it starts getting thin. It's just all going. I'm going bald. Yeah. Anyways, how have you been holding up with the Corona situation? Which is just yesterday we got some exciting new
restrictions.
Yeah, but not much is changing for me. At least.
It is. So I was also thinking that not that much is changing, but one of the things that I think is really significant is that in persons now also children are counted. So
are they?
Actually, I'm not allowed anymore to take my daughter to my parents because I would be like one family plus me
too many.
And an additional person. Yeah,
I thought it was still like children under 14 aren't counted, but that's okay. That's
pretty significant, and I don't know if like everyone's really aware of that. I think it's the right step, to be totally honest.
I still wish they would do more because it's still, hey, you can still meet with people, you can still, go shopping, you can still do basically everything.
Yeah.
And reasonable people probably have been living or have been restricting themselves to basically what is now law for everyone for the last months anyways.
Definitely.
So,
well, we're basically just like paying the price of, well, the stupidity of others.
it's also the politics always tries to find compromises, and like we saw the travel or the mobility restrictions where you can't be further than 15 kilometers from your place of residence if the 7-day what's it in English, cases per
Incidence?
100,000 is
Something.
over 200. And the original suggestion or the original position was, okay, if it's over 100 per 100,000 people. And now it's like, well, we made a compromise and it's 200. You can't make compromises with the virus. Like, it doesn't care.
No.
Yeah. And I put the corona topic in here just because we talked about this briefly before we got started here, but I feel incredibly stupid for, casually mentioning something like, oh, they said it's just another flu at the beginning of this year on one of the episodes. And it's like, damn, you should have known better. And just to be completely open about that, like that was when almost nobody knew what exactly was going on, and my position changed pretty dramatically after that. And it's like, well, this might actually kind of suck,
Yeah, you are definitely right about that. Let's just hope that, I don't know, we're still like basically in the middle of winter, but with spring and summer and vaccinations and stuff like that, things are getting more and more to the way, well, they basically used to be. I was actually looking forward to, so I have an additional 2 months of parental leave this year, and one of my big dreams actually was to just rent an RV. That's like double. Well, to rent an RV in the US and do like whole East Coast, then to the West Coast, and all the way up to Seattle. But that's definitely not going to happen. Then the next plan was to just basically do a big Europe trip in like May and June before like the big holiday season starts. But just as it looks right now, I'm also not really confident that's gonna happen.
Yeah,
which kind of upsets me. But I'm okay with it.
Because the hope was, okay, in summer it's all gonna be over basically, and there were voices that were saying, okay, by summer we're gonna be able to provide a vaccine or we're gonna provide a vaccination to everyone who wants it, which right now it's not really looking like that's gonna happen. My dad's already planning for, we skipped our annual bike trip last year. We were gonna do I think southern France or something, and he's now planning for this year, but I think I gotta like bring him in a bit more because that's probably not gonna happen either.
Yeah.
Oh well, but we do what we must, right?
Indeed. Yeah, I'm unhappy about it, but I definitely do accept it for the health of my family and everybody else.
Yeah.
There's hopefully going to be a post-corona time.
You've seen the memes like, hey, this is COVID-19 and New Year comes along. Oh, this is COVID-20. This is COVID 2021. Yeah. I generally I try to be an optimist, which was again why I was like, okay, if this is just a flu, then that's fine. Which is why, when we were rushing to Chicago airport, I was like, we've got time. I tried to be an optimist. I tried just not to work myself up over stuff I have no control over. So
we'll be getting over that. We shouldn't talk too much about that topic. Well, at least start the podcast on that topic.
Yeah, so let's just pick another topic, right? Belt printers. Second
Belt
one.
printers.
So
You have yours, I have mine. I have printed
Where is mine?
at least a little bit with it. I don't know how much you did with it. How happy or unhappy are you with it?
So I have the one with the like second generation belt. I think Joel has the one that has the super sticky belt, as do a lot of other early reviewers.
Yeah, I also have the same one as you do.
And we have the like it feels very dry. It feels very hard, and I've been having massive troubles getting stuff to stick to it at all. When you have a printer that can print extremely large parts, you also want those large parts to stick down, right? It's not just okay, small parts need. So that was a major challenge. I have since received a V3 belt, which feels a lot more rubbery, a lot more tacky, actually. I think it's also got a slightly finer mesh weave, but that might be. I'd have to really compare them one to one. And I've not put that on the printer yet. The printer right now is disassembled. It has the belt platform moved from the frame, which is surprisingly easy to do. And yeah, I need to put the new belt on. I need to readjust it and then try some of that stuff out. So yeah, that's all I've been doing with it.
Okay. Yeah, that's basically also kind of a similar, I don't know, challenge that I also faced with my CR30. It is definitely a nice, sturdily built machine, but my biggest challenge so far was also just getting prints to stick on the belt. I tried different filament. I tried Idea Maker, but with Idea Maker, I don't know, I don't get anything to stick on the belt because I think so far it doesn't include the modifiers that the layer that is put on the belt is printed slower and at an increased extrusion multiplier. And I think that's one of the bad things. I also kind of chipped a little bit away from the silicone socks where you also had issues with. But yeah, sticktivity of the parts on the belt is definitely a challenge. And in this case, I'm actually quite happy that Naomi was able to ship this machine out to a lot of reviewers because, well, before the Kickstarter was over and before they even started delivering the printer, because that now gives them the opportunity to fix those things. Because I think at the current state, the belt might, I think, definitely be an issue.
Yeah, with the one that we originally received, I think people would have been very unhappy with that. And I mean, you've seen tips like, hey, I'm just going to drench it in hairspray, or I'm just going to add stuff to it. With a textile belt, that kind of feels wrong because you're never going to get that out again. But yeah, rather have some beta testing going on than shipping something that is going to be essentially broken to thousands of, I don't know how many backers were in there, but to thousands of people, let's just say. What I'm also really starting to notice is just how limiting the 45-degree angle is. Okay. And it's like a lot of stuff I feel like, okay, I might be able to print this on, or I want to print this on the belt. It's like, well, but overhangs, you're going to have to print it with all supports. And it is very limiting. I kind of wish at this point that they would have gone with like a 35 degrees is the shallow one. That would enable at least some amount of overhang in which direction? No, away from the nozzle. So yeah, 45 degrees just puts you at right smack dab vertical, and that's it in one direction. So
and it would probably also have increased the pressure of the material onto the belt and helping it adhere to it.
Yeah, which is one of the things I already did with mine. That metal plate that the hot end sits on, I slightly bent that down so that the hot end isn't perfectly in line with what the mechanical axes are, but it's like 5 or 10 degrees pushed into the belt, so that it's not like it almost feels like, or it almost looks like it's kind of shooting the filament out over the belt instead of pushing it in and on. It's just like squeezing it over. So that shallower angle might help with that. Yeah.
So with a sturdy design, I think it's not as easy to modify the angle as on some of the other machines, because you basically would have to shorten also like the front extrusions.
Yeah, those, and you need a new rear plate.
Yeah.
That it should not be too hard, right?
It shouldn't be too hard.
You can swap those extrusions. They're just standard 2020s. Should be doable.
Yeah.
And it's something I actually do have on my video list for the next couple of months, because I feel like it's an innovative process, or an innovative machine as is, and it like enables so many more things, but the practicality of actually using it as a normal 3D printer and not just printing swords and stuff kind of suffers from that very steep 45-degree angle.
Yeah. That begs the question, like, how shallow could you go? So like the 0-degree angle is basically protected by the patent, but is 0.1 degrees, would that be something that's possible, or is that still within the tolerance range? Because, I mean, as we already discussed last time, converting this machine in like just a Core XY printer that has more or less a movable bed would be not hard to do, and a really cool solution.
Yeah. You do run into some practicality issues if you go too shallow. The shallower you get, the lower your like Z height, perpendicular to the belt goes. So if you go, I think 15 degrees is the lowest you can set in Cura. If you go to that, you do lose a very significant amount of your Z height. So I think you would need to add like a separate Z axis to
Z2 axis.
Yeah, to the Core XY assembly that raises it up. But that, I think that kind of gets pretty complicated for slicing, because now you have to like separate your layers that are XY on the Core XY into separate sections, and then just print one move up and then print the front. That could be very challenging. But yeah, I think so. Most stuff I print isn't very tall, so I think if I modify them, I might just go straight for the 15 degrees.
Yeah, that's probably really interesting to see how that changes the usability of the machine, and also what you now can and can't do with it.
Yeah,
cool. No, I'm really interested to see how that progresses. I don't know. Did you already receive a firmware upgrade from Naomi?
I did not.
Do you still? Okay. Because I think it's still, there's still a couple of things that Scott Lethine is still working on, and I'm looking forward for them to be implemented in the machine itself.
Yeah, I actually do appreciate that they're working with the people making the components they're using, Marlin firmware. Scott is the developer for that, or the maintainer and main developer, I guess, for that. Not just grabbing it and being like, oh yeah, we added our own stuff to it, and now it's, good luck doing anything else to it, because we broke everything else. They're trying to do it the proper way, and I feel like Creality is, if you were to choose one manufacturer, one Ultimaker, Prusa, non big Western manufacturer, I guess it would be Creality that does things the most properly, with documentation and software and the way they develop things. They're shaping up pretty well.
Yes. I would be interested if that's just due to the reason that Naomi is kind of consulting them and working with them, and she has a way closer connection to the community, or if they also see the benefits in that. I think it's, I would say that many of the things that we got from Creality are due to the work that Naomi did in the past, starting with the power loss detection, like 1.5 years ago or something like that, where they didn't want to release that, and people were like deleting purchase links for CR10s and stuff like that from their video descriptions and stuff like that. And she stepped in, and she was the one who was basically able to convince them to release the source code.
Right. I was not aware of that.
Oh, no.
Yeah. I mean, there's stuff that it's just, there's so much going on. You can't know it all. Yeah, but that's okay. Okay, that's good. I mean, yeah, a lot of the manufacturers, if they go unchecked, if they just do their own thing and they're like, okay, we made the business decision to do X, Y, and they run with it and get no pushback, then it just validates what they're doing, basically, right?
Yeah.
Yeah.
Cool. Yeah. Also, maybe just one last thing. As I said, I was trying to use Idea Maker for belt slicing. I'm really happy that they kind of invest work in that direction. And that they also already provide the software as a beta version at the moment. Still a lot of issues left, I think, just with like the process of slicing at a 45-degree angle works. But I think that's also just getting us a step forward, because if we would just stick with the black belt Cura that is based on Cura 3.6 or something like that, we'll probably wouldn't be able to just get all of the potential out of that new kinematics. I don't know.
Yeah, and it never hurts to have, at least a choice of, hey, am I going to use software A or software B? And, when you have one piece of software, it's that there's a vision behind it. Well, I guess with bigger projects, there's like a whole management team behind it that dictates the vision. But you see with like FreeCAD, I guess. FreeCAD, small developer team, they know, okay, they want to get something that they can use, and they have their own priorities and what they think is important and what isn't. But then when something else comes along and it's competing with it, even if it's two non-commercial projects, it's like, okay, we can see these guys took a completely different approach, and it might be better, it might be worse, but it's at least something else you can check against and see, okay, what we're doing is better or worse than what they're doing, and it just works in everyone's favor, I think.
Cool. All right, shall we proceed with 3D printing news?
Oh yeah, we've got four bunch of topics in there today. So you put in the first one.
I put in the first one, and I called it 2 times faster 3D printing.
Wow.
Sorry for that, guys, but again, it's a Kickstarter project called Ulendo. Maybe some of you still remember the picture of a White House being printed very fast, once with a totally new acceleration algorithm and once with like just standard settings. And with the standard settings, you had layer shifts just because the printer got into resonances and stepper modus skipped steps. And then there was like the acceleration algorithm by the University of Michigan. Is that right?
Is that the one that's in Clipper? Okay, so sorry.
I actually stumbled upon that one algorithm in Clipper. I think it's something different, but I think they're both going into the same direction.
Okay.
So they basically have a new acceleration algorithm, but instead of like releasing the technology and making it available for firmwares, they started a Kickstarter with a project called Ulendo, which is basically a cloud service where you subscribe to, and then you connect your printer also, I think, to a Raspberry Pi, but the G-code is not streamed via Octoprint, but basically via a browser window to the. Sorry, aren't they? I think they're not streaming G codes, because that wouldn't make any sense.
Yeah, what I'm trying to figure out. I'm looking on the Kickstarter page right now, which by the way has 27 hours to go when we're recording this, and is not looking like it's going to meet its goal. But my question is, what is their product? Because if you have a cloud service or something that is separate from your printer, and you're saying, hey, it optimizes acceleration, like it's the firmware on the printer is still the same, right? That does linear acceleration. Are they chopping that up into small acceleration segments, or how are they doing that?
Okay, so I didn't go into. I didn't read it all. What I basically blah blah blah. So you are, I think, basically interfacing your printer with a Raspberry Pi, but the 3D printer needs to have a new firmware. I think just as with Clipper, that is not taking G-code commands, but I think it's directly taking like step commands. And so what you are basically purchasing is a user license to use that service on your printer for a limited amount of time. But the thing is, it's not universally applicable for any printer. And as they state in their Kickstarter, the first printer that's going to be available is the Lulzbot Task 6, where they tune the settings in a way that you should be able to print 2 times faster. If that's possible or not, that's a different question. But just then starting from that, every couple of months they will release that product also for a different printer. And I think that involves specific firmware and specific settings for the cloud service.
Yeah, just found it here. Install open source firmware on your Raspberry Pi and 3D printer to allow them to connect to the cloud server running Ulendo. So you do replace the firmware on your printer, which is, so it's Clipper with a web service.
Yep, and Clipper with web service
with pre-configured profiles. Okay. Yeah, I think the way they're failing here is just that they're making it way too obscure what they're actually doing. They're mentioning modified B-splines somewhere as their means of doing acceleration, or filtered B-splines. Sorry. Filtered B-splines. That's basically if you have like any vector tool and you have those splines, right? Or keyframing. That's filtered or B-splines. And then what the filtering is probably just filtering out just a frequency filter, basically, that reduces the frequency at which your printer resonates and just leaves all the other frequencies in place.
It would be really interesting. So you mentioned Clipper before. Clipper has a feature called input shaping, which also needs to be tuned. But then this also allows you to significantly reduce the vibrations on your prints, which in the end allows you to print faster. I personally have never used Clipper. Should probably do that at some point.
You've probably done the groundwork to enable that feature with your resonance testing and stuff.
Maybe. But that's pretty cool. And I don't know, I just stumbled into a rabbit hole of input shaping for, I don't know, container movement and stuff like that, which took a couple of minutes of my life yesterday. But yeah, coincidentally, it would be interesting to see how their algorithm compares to input shaping. But I think they're basically doing something pretty similar. One reason why I think that their Kickstarter failed is because they are at first making it available for a printer that, I don't know, is not really that common.
Yeah.
If they would have made it for an Ender 3 as their first priority, and if it would have already been working, because they say they will release the working like cloud software like mid next year. So there's still quite a bit of development necessary. But if they would have had something working for an Ender 3 or some other printer that is way more common, I think way more people would have jumped on that bandwagon.
Yeah, I think the cloud service, which is basically what's locking you into their software as a service, nobody cares that. Nobody wants that. What people want is the acceleration tuning and the speed tuning, and the server part is just what they need to manage their licenses.
Yeah.
Oh well. But yeah, we should probably look into Clipper. I keep getting suggestions of like, hey,
have you ever used Clipper?
I might have used it once, but it's been many years.
Okay.
Yeah.
In that rabbit hole yesterday, I saw a video of an 8-minute Banshee done on a Delta printer.
I've seen that too. Yeah.
Which didn't really look that bad, and I thought, it would be a really great project, like building a horribly fast 3D printer for myself, because we have discussed about that already in the past, but I'm the impatient guy. If I want to have a part, I would rather have it in half of the time as having like double the print volume.
And for this reason, Voron. You've seen build a Voron. You've seen those right? Full Core XY VORON. It's the printer everyone suggests if it's like, hey, I want a DIY printer. That thing is baller. I mean, completely over the top. Belt-driven Z-axis with 4 motors, so the Z-axis actually goes faster than the X or Y. Full Core XY platform up top, fully enclosed. It's pretty crazy.
Okay.
If you want something fast, like I think that's one of the best bets.
But I thought about that this morning, and I think I would rather go with a Delta printer and strip the hot end down all the way so that it's as light as possible. I don't know if...
But why are you worrying about vibration and ghosting? Like, we just talked about this. We've got Clipper. You can... Why do it in hardware when you can do it in software?
Sounds like a challenge.
Yeah, it's one of those magical things where, we've talked about this before, but software is like, hardware has progressed to a point where it's just like you're getting diminishing returns. You can put more and more effort into it, but at some point you're always like, you're saying, wait, you want to make it super light. You're always going to have some sort of a heater block, some sort of a heater. You're going to have wires. You're going to have connector parts, bearings, all that needs to be moved. And at some point you're not gonna make it any better by stripping more weight. You're gonna make it less rigid, in fact. So there is a limit to how far you can go. So now software comes in and takes you that extra step. And there's still a lot of untapped potential there.
I'm so tempted to do that. I don't have the time for that.
Yeah, same.
Okay. Yeah, I'll just keep that in mind. Voron design.
Yeah, they've got. It's a community enthusiast project. It's totally open source. They've got 2 different printers, 2 different models. They've got the is there a name? No, there's just the Voron 012. So I guess the 2 is the newest one, and they've got the Switchwire, which is I think a more compact one.
Okay.
Or a lower profile one. Yeah, you can get the full CAD designs. I've imported that into Fusion already, and you can. It's crazy.
Cool.
It's absolutely crazy.
Need to take a look at that.
Yeah.
I think it would not necessarily. So if I just out of my head, if I would design something like that, I think I wouldn't make the build volume bigger, like 150 by 150 millimeters.
True.
Because you want to have it as sturdy as possible.
I'm pretty sure you can scale down the design. Just make the V slot extrusions. Yeah, make those a bit shorter, and it should be fairly straightforward. Well, there are a few printed panels, but they're not like essential for function.
Yeah.
Yeah, that is
okay.
That's that.
I'll think about that.
Voron. That was one more thing that I wanted to bring up. I don't know. Yeah, I was looking into it because I wanted a printer that had a Z-axis or a bed, basically, that was completely separate from the XY. So, wait, in the Voron, yeah, the bed is completely static. So it's not even moving up, down like in an Ultimaker, but it's literally static. And I needed something that would allow me to replace that with something that is large, heavy, and chunky. But that might be a project for another month.
Okay.
I need to build the Voron first. Yeah, so that was fast printing by Ulendo or with Ulendo. Unfortunately, not finishing the Kickstarter or not completing the Kickstarter successfully. Another approach to fast 3D printing would be the rotational 3D printing. That's actually been something that I've seen at not Formnext, FabCon and Repitech, I think 2 years ago or something, which was at that point a research paper by, oh god, I'd have to look it up. The interviews on the channel from FabCon, which I recorded, and yeah, basically what they were doing is they were taking a round glass container with resin in it, and they were using I think a DLP projector, some sort of a projector, just projecting through that resin. So basically you had like rays of light that would cure the resin going through the entirety of the material, and then you were rotating that pod slowly, and with every rotation step you got like a new angle of where your object was. You were looking at your object from a different angle, and you were exposing it with that view, basically. So it's reverse not
CT scanning.
CT, not MRI scanning. Yeah, reverse CT scanning, and basically the prints were done in I don't know, a minute, 30 seconds. So you basically reached into that pod and was like, there's your part, it's done. And that was incredibly impressive, and it looked like they had it pretty much figured out. So now we're seeing that process in a product. So that is XOLO, XOLO, they're calling it xolography. And basically it's exactly that in a finished product.
Did they say when they're planning to bring something like that to the market?
The researchers?
Solo.
Hold on. I mean, this is a availability. Let's see. Early in the development process. Okay. But yeah, it is being put into a physical product. That's basically the news. And it's always nice to see research papers and experiments like that actually turning into a real product, and not just something that sits on a shelf, or worse yet, gets turned into a patent that then gets sold to some sort of a patent troll and never used. Yeah. That sucks. But yeah, this is an actual product, and at some point you're going to be able to purchase a machine based on it.
Yeah, unfortunately, it's probably going to be like a proprietary process. So unfortunately, I think we won't be seeing that like cheaply available for a while.
Yeah, well, I don't know how much of that process has been patented already. But the process itself is not something that is like super complex. I think I've got a DLP projector. I've got some resin in the circular container. Like I could probably reproduce that with little effort, except for like the software part, which, I mean, once you know how it works, I don't think it's too hard either.
No, it's not too hard. There are actually open source softwares around where you can do put an STL in there and basically do CT scanning on that STL file. This is available, and you can. I think, just from how I understand it, just take those images and basically project them on the resin.
Yeah.
For me, it would be interesting to know if the resin is also key part of that process, because I think what's important there is that the resin doesn't like gradually cure.
Great question.
So great question.
Yeah. Exactly. And that was actually at FabCon. they actually hired me to record all the talks. So I was running like 3 or 4 cameras, and I was also there, and I was genuinely interested in some of the stuff that was being talked about. And one of the questions I asked for that topic was, what do you do with like the half-cured resin that you have naturally occurring, where the light still passes through, but you don't get a part? And the answer was pretty simple. You heat it up and it resets. So apparently that's something you can do with resins. When they're activated by light, like apparently there's like a threshold of how much energy it needs to absorb for a certain volume for it to actually start curing. But once you heat it up, I think it was like 60 or 70 degrees or something, it resets, and I'm sure it's not like infinitely repeatable, but it keeps the resin from like completely spoiling.
Okay.
And
did we
apparently
already talk about?
Yeah.
Sorry.
Apparently that's with regular resin, like nothing really special.
Okay. So because this was my question, because I was asking myself if you need a special resin that basically is in its uncured state until it absorbed a specific amount of light, and then just at some point, like from being totally uncured, going to the cured state. Because if you would not have that, you basically have a big blob of goo only in your vat.
Or you would have to basically toss out your entire resin vat every time you print.
Yeah. Did we, like in one of the last podcasts, talk about the 3D printing resin science video that Goobertown Hobbies released?
We did not.
Did you see that?
I did not.
I need to put that's really interesting. So I think this guy is usually painting miniatures, but he is a PhD chemist, and he made a 30-minute video on 3D printing resin science, where he talks about how the different ingredients in a resin work together to make it photosensitive, and also talks about why Elegoo bioresin is just a bullshit claim. Definitely watch it. I'll put the link into the show notes. It's really worth watching. It's a great video.
Please do. Yeah, it's resins. I mean, with filaments, it's pretty simple, right? You have a plastic, you get it hot and it gets soft, or melts, casually speaking. But with resins, I'm not super deeply into it, but it's a bit more complex than just getting it hot and getting it molten.
Yeah.
And most people, myself included, aren't like completely aware of how that stuff works. Yeah. It's just, hey, I get this liquid, I shine some light on it, and it gets hard. Like, that's all I need to know. But yeah.
So yeah, if you want to know more in that direction, really check out that video.
Yes. And we're also going to have the original talk from FabCon in the description down there as well. So Stefan, if you're interested in the backgrounds of that, have a watch as well.
Yeah, cool.
Okay, so that is rotational printing or xolometry. X is a weird letter.
All the time I hear that, it just reminds me of Xerox. Solo, right. Xerox, which is, I don't know if they want to make a really bold claim that this is the new way of printing, like Xerox was the totally new way of copying stuff. Just, I don't know, I always Xerox have it in my body.
Did Xerox actually invent the photocopier?
I don't know if they invented the photocopier, but I think it was also called xerography. Was basically like the Hoover or the Tempo or the I don't know,
whatever you have. Okay, wow, they've been just looking at Wikipedia here like that. I know that's fun to listen to, like two dudes looking at Wikipedia. They've been around for a while. And yeah, there's a whole... Okay, we're not going to go too deep into that. Anyways, moving on. So that was a it's the third video for fast print. That's the third topic for fast printing today. So we've done the acceleration optimization, we've done rotational printing, and now we have fluorescent switched SLA printing. Another article from Fabulou. We're on Fabulou, which is it's another resin printing process, but it's God, how do I explain this without the image? That's gonna be tough. Okay, so typically on an SLA print, now that the comparison does make sense. So again, like in the rotational printing, you start with a vat of resin that is, or a container full of resin, and you're doing kind of the same thing. You are projecting an image through the entirety of the resin, but instead of rotating the container and kind of relying on the intersections of where the material absorbs the most energy, you're leaving the vat static, you're leaving the projector static, and now you have a second axis that is basically a line laser, or a line laser that activates one plane of the resin, of the liquid resin, and basically moves through the resin. I guess from back to front would make sense. And then wherever that secondary laser activates that one plane of resin, it can cure from your projector image. So that's it. The interesting part about this is you have your part suspended in resin. You don't move it. You don't have to peel it from a surface like you do with traditional SLA printing. And I don't know if it's certainly going to be faster than SLA because you have no moving parts for the resin part itself. You're just basically scanning through your resin vat.
So is then like the interaction between the line laser and the projector the reason why the resin hardens?
It's
or
so
cures?
Not quite. So it's not like you're taking what's that process where you're like engraving a 3D image into a glass or acrylic piece? Holographic? No, something. It's not like that where we're basically focusing on a point in the resin. It's literally that line laser is activating the resin itself for being receptive to the projector, and it's two different wavelengths. The activation pattern is basically it's UV light. It's 385 nanometers, and then your actual image projection is 532. So it's a green projector. And by default, the resin is not susceptible to hardening from that green light. It's only susceptible to hardening where you hit it with that UV projector. Now, one thing that actually comes to mind right now is that activation by the UV LED, is that reversible? So is it only activated where you get the UV light hitting it, or is that like you're basically consuming that part of the resin by hitting it with UV, kind of like you're hitting it with UV and then it hardens forever? I don't think the article is very clear about that, but yeah, it's
in the article they are talking about a patent that was released, or is there already like a working prototype?
Was granted a few weeks ago, so it might just be the patent. But whenever there's a patent, I'm my optimistic mind says, okay, there's an actual process behind it. Because they are very specific about, okay, we need green light to activate this. We need a UV we need a green LED projector to project the image, and we need a UV light to activate it. It feels like they've actually done it.
Okay. I think in either this or the other article they were talking about, okay, so this removes layers and steps and stuff like that from 3D printed parts, which I find kind of misleading, because you're still using like a discrete projector that has discrete pixels, even though they might be washed out a little bit more.
Yeah,
you still kind of expose voxels or pixels or pixel layers or things like that. So
Yeah, with
It's
even with the rotational one, where you would where basically if you have individual pixels like in the X direction and you're rotating about Z, you are smearing those X pixels together, but in the Z direction you have the Y axis of your projector and it's still individual pixels, so you're still getting layers essentially. Yeah.
Also, one of the interesting things or downsides, well, which I know from CT scanning, is that, for example, the rotational axis is always an axis where you can't really, where you have problems, just because it's basically always exposed, and also layers that are perpendicular or no parallel to the X-ray beam in CT scanning, probably also in a similar way in here, where you have problems of getting a same resolution as on other surfaces of the part, or the same amount of details. So I think it's still pretty tricky. It could still be the case that maybe in the beginning the applications are, well, not totally broad, because some parts just don't properly print that way, but also due to, well, different processes and different ways of creating the pictures, so software basically in the background, this could also be improved.
Yeah, but as always, every process has its limitations, and I'm sure these like suspended resin printing processes, these two different ones, they have their downsides, they have their limitations, but they also have massive upsides versus what we're traditionally doing with SLA printing or laser SLA, or FDM printing, which by themselves, I mean, we've gotten used to all the things they cannot do. And now we're just getting a different set of rules basically. As far as what is saying with like I see that when you're basically taking a slice and then looking up top on that slice, I'm sure you can't reproduce every possible combination of details. I'm wondering if that's offset by the fact that the projectors typically don't beam their light through it perfectly parallel, but they're actually kind of widening up, so you're not your layers, as you rotate them, they're not like flat layers that you just spin, but you're actually projecting through the layer at a different angle every time.
I think but I'm not sure about that. I think the basic idea is that the beams are parallel, because otherwise it might not properly work, but I could also be wrong. No, I think if you do CT scanning, also your X-ray beam is spread out. I don't know. So forget about that.
We are not involved that deeply in that.
No, we are not involved in that. But maybe just on that remark, why can't we print continuous on our just like basic LA Mars MSLA 3D printers? So why can't we move our Z-axis continuously and always cure the layer that is like the closest to the resin vat? Is the reason for that well, somehow resin needs to flow in there, so maybe you need to would need a something like optics to focus your image at,
so do it on a different plane.
Do it on a different plane. Just on that mark. Why isn't that more common? Because I don't know. I see this as a way more low-hanging fruit.
Yeah. Well, okay. So if you focus on a different plane, like you're always going to cure the resin that's like below that plane as well, even if it's even if it's blurry and stuff. Yeah. Unless you use that second patent that we have here, without that second approach. But with the traditional hardening process where you have an LCD that gives off diffuse light, basically you need to cure like right up against that LCD. And I think there might not be a curing point where you both get a model that is rigid enough to support itself and to support details, but also does not bond to the FEP film. Because if you have something that, if you cure enough to the point where it starts bonding to the FEP film again, you're gonna get slipstick basically. You're gonna cure some to it, and it's gonna pull the FEP up, and then it's gonna release again, and then that's not gonna work. So or you would need something that is like so resin repellent that you can cure it a lot and then just lift it off by moving up. But that might be a material that doesn't exist.
But then you still would need to have a way that new resin flows into, well, the forming gap. For this reason, you basically would need to have a bigger gap and focus your image in a way that you have an image plane which is above the bottom of the resin vat. And I don't know if that's just, if the reason why that is not that common is because there's a pattern that you need to have optics to focus it on a different plane or something like that, or if it's more complex than I currently think. I think it's interesting because I think I've seen continuous Z-axis 3D printing, and I was asking myself, okay, why isn't this not possible with basically a more or less standard 3D printer? Because the current ones, they just have the screen. They don't have any optics.
Yeah.
And they rely on the fact that your resin is basically very close to the screen so that the image doesn't blur out.
Exactly. What is the clip process by Carbon? Because as if I remember correctly, they are advertising that as continuous. Oh, okay. Well, it's exactly what you're describing. So I found an article on 3dgrenzenlos.de. They're basically doing exactly that. They're creating a dead zone, which is a thin layer of non-hardened resin between your image source and your printed object. So that's where it can flow back into it. How are they doing that? Okay, by adding oxygen. Right, so that they're basically, I guess that they're creating they have a permeable membrane between your projector source and your resin vat, and it kind of gives off oxygen into the resin, or it enriches the resin with oxygen at that point, and that's where the light can pass through without actually hardening it. So I'm guessing the oxygen somehow then gets dissipated again, or gets removed from the resin, or I don't know what happens to it at the point where it then hardens. So you need that layer for the resin to flow back in. But like how does it get rid of the oxygen again? But yeah, it's a solution to the exact thing you were describing.
Yeah,
100 times faster. And I'm sure there's a patent on it. Like,
which is probably the reason why it's not that more common, because I think other companies would have jumped on that idea if they can print 100 times faster and not just 2 times faster.
Yeah, well,
as Ulendo promises.
Why do 2x when you can do 100 times? On the topic of patents, just because it fits in, you guys have probably, by the time you guys have seen the video. Stefan, you've not seen this before. This is the by the time we're releasing this podcast, the video will be out. This is the WhamBam Mutant. It is a quick change tool system, patent pending, that basically it gives you, that's the assembled part. You have a mobile plate that has an electrical connection to the base plate. Base plate mounts to your carriage, to your whatever, and then you slide them together. I don't know, we can see it like that. You slide them together. It's a dovetail mate that tightens up at the bottom. Slide it together, push it in, and then you lock the lever, and it's solid. So basically you get electrical connections, you get a mechanical joint. It's all injection molded plastic, so it's pretty robust. And it's patent pending. So this is something that WhamBam's going to be able to make, but nobody else is going to be able to reproduce or use in some way that is similar to it. Now, why am I bringing this up? Well, patent pending. We were talking about patents. There's another quick change tool system on Kickstarter right now, the X Change. patent pending, which is different. So the exchange is more of so it's got 4 pins that basically go into sockets, and then it has a magnetic catch on that. So you have your XZ forces captured by those pins, and then the release in the Y direction, I guess, is just the magnet. But yeah, it's kind of bothering me that all this stuff is so quick to get patented. Like, I don't know what exactly about the exchange and about the mutant is the patented bit.
Mm-hmm.
But it's so sad. We only have 3D print. We have 3D printing exclusively because the original FDM patent expired. We don't have belt printers because there's a patent on it. We don't have what else was I going to bring up? I gotta check the script. But we don't. Yeah, heated chambers. We don't have them. We can't print PEK because there's a patent on it. There's so many things that are being locked away by patents these days, where it's like we're going back into the dark ages. It almost feels like we're going back into the dark ages of the 1990s, where stuff was just inaccessible because it was a minefield. And it looks like it's again becoming a minefield by so many companies immediately patenting their crap. Sure, this is a good system. It works. I mean, I see there's development effort being put into it, but what's the patentable bit about it? Is it the fact that it's literally a quick change 3D printed tool platform that uses a dovetail? Is that it? I feel like we're missing out on so much.
But this is the problem with patents and why there are patents, because either people spend their spare time developing stuff, but as soon as a company gets involved and needs to invest in injection molds and other R&D work and design iterations and things like that, they kind of have to make sure that they got their return on investment. And the only way, more or less the only way they're able to do that is to patent their stuff, because otherwise, like 3 weeks later, you have the same part looking almost exactly the same for half of the price coming from China.
But it's not stopping them. It's not working. It's not stopping China. You can get slice engineering mosquito clones. That's a patented system, but you can buy it. They theoretically have a means of stopping the imports of those, yes, but does it work? No. Yeah, so...
Yeah. But I don't know if that's really an excuse for not patenting. I'm already missing the words.
Yeah, but...
you know what I mean.
Yeah, so in principle, patents, yes, sure, they're a great idea. They give you a competitive advantage by making sure you are the only company who can legally use that process that you developed, right? That's the thing with patents. But patents also have the limitations. Like, they theoretically, not in practice, it's entirely different, but theoretically you can only patent like non-obvious things, which includes combining two pre-existing things into one, like saying, okay, we've got a tool change and we're using a lever. That shouldn't be patentable. Or we've got a dovetail and an electrical connection. That it needs by law it needs to be more complex than that. Again, I'm not a lawyer, but that's my understanding of the thing. And it's like, it's a patent. If you look through the patent script, the patent text, it's so far abstracted from what the actual thing is. And it's like, okay, apparatus A for use in where apparatus uses XY, where apparatus uses Z in combination with that. It's like they're going so broad with their applications, where it almost feels like you can't innovate anymore. You can't make a complete innovative product without bumping into everyone else. And again, I'm not against patents. It's just 20 years is a long time. 20 years might have been fine in like 1830, where the difference between 1820 and 1840 was were twins? Yeah, surely. Steam engine and slightly faster steam engine. When were steam engines around? Roughly correct, right? 20 years was fine for that. But nowadays, where 20 years is literally the difference between, oh, my computer is a gray box that, maybe runs, I don't know what, Prince of Persia 1, to, oh, cool, I've got the processing power of a supercomputer in my phone and I can reach anyone in the world. 20 years is way too long for that. Oh, my supercomputer just burst. It's just frustrating, and it's keeping the entirety of 3D printing, and I'm sure other industries as well. It's keeping it back, because there's just one more thing before I hand over to you. There is a concept called fair and reasonable something licensing, where patent owners can be forced to sub-license their patents to competitors when, for example, it's the patent to access the 5G network. Stuff like that is classified as friend. But most of the stuff is not friend. So yeah, the patent owners now have the ability to basically keep everyone else from building something similar. And at that point, basically your engineering time is spent working around patents and not actually developing new stuff. You're reinventing the wheel over and over again just to evade, those core patents and stuff. Okay.
Maybe just on that note, patents don't always need to be like offensive patents. Companies patent a lot of stuff.
True.
For defensive terms that nobody else can come around and say, okay, I patented that and you can't do this anymore. And this is also a totally legitimate way that you are patenting something to have, like, at least for a short amount of time, that you don't have to don't have to publish it already during, basically when you had the idea. You can develop the product, patent it, bring it onto the market, and you have, at least for a couple of months to a year or two, a bit of an competitive advantage, because you already produce the parts and can sell them and stuff like that. But your main goal is not to enforce that patent on others. So you basically just say, okay, I don't want anyone else to prohibit me selling that in the future. But if somebody else is making basically the same, I won't enforce it, because I kind of honor, for example, the work that companies do around 3D printing and trying to evolve it.
Yeah.
So I don't know what they have in mind. A patent is costing a lot. I don't know if this is just an American patent, if it's a European, Russian, Chinese, whatever patent. But there can be also different reasons than to just block the market or block others on the market to make something totally the same. Because defending a patent can also be really expensive.
Yeah. And maybe you don't even want to defend it. Maybe you just want to own it and say, hey, I own it, without actually going to trial and getting it challenged, basically.
As I said, as defensive.
As in your patent is bullshit, and you don't want a judge to say, hey, this is bullshit. Okay. You just want to have it in your patent pool. Because that is something that also happens when, a company gets sued for patent infringement. It's like, yo, I've got this patent that you're infringing on. The company can say, well, but I've got these 50 other patents that 90% of might be irrelevant, but they can say, okay, I've got this patent pool, and let's come to an agreement that you don't sue me, I don't sue me, or you drop this, I drop this, and we're good. Like, that's something that very often happens, where basically the goal of a company is to have a patent pool that just is numbers, that is very little substance, but just we need to have enough patents to, in case somebody else sues us, we need to be able to say, okay, here.
Companies and departments are sometimes also measured or rated in how many patents they release every year.
I'm not saying what. Well, my point is the system is broken. it's kind of like a don't hate the player, hate the game situation. Like the system is broken, and I can see why companies are patenting stuff. I just disagree with it entirely. Just one more note on defensive patents. It's a noble move to say, okay, we're only going to use these patents defensively, but you do have to document that somewhere, because otherwise everyone's going to assume you are using those offensively. I think Tesla at some point said, okay, we're open sourcing our patents. We're only going to use them defensively, basically. We don't sue you, you don't sue us, kind of thing. They might have stopped doing that. I'm not sure about that. But yeah, if you're saying we are just keeping these in the portfolio for our defense, then make it public and make sure people know about that.
I'm quite sure if you would go through the RepRap forums or Facebook or whatever, they're tool changing and having a connector in that block is probably something that somebody else already thought about.
Oh, absolutely. Absolutely. RepRap forums.
Yeah, defending that patent before a judge, as you already said, could be hard.
Yeah, but that the goal of a patent, the goal of a competitive advantage is already achieved by the time you get the patent granted to you. Like just having that, it doesn't matter if it doesn't hold up. As long as you have the patent number on it, that's good enough. That keeps others from trying to replicate it, because then they have to go.
Cool.
It's kind of a it's a turn off for me if something says, hey, patent pending or patent number XYZ.
But it's a turn off for you, for probably 99% of the rest of the world.
Sure.
Patent pending on a product, it just means this must be quality. This must be proper engineering.
This must be something new and innovative. Yeah, it's like as seen on TV. It's that it goes, same breath as that. Yeah, but okay, back to this. I'm gonna have a video on this, but yeah, tool changing. There's more and more tool changing stuff coming out, and there's different solutions to different problems. So the way I see this one is it feels a bit rough and clumsy, and the injection molded parts are warped, and it's like, yeah, but once it's clicked in, this is solid. Like you could probably put like one of those 450 watt router spindles on it, and this would not be the weak point. Super solid, but it doesn't allow for like automatic tool changing like you'd see on the I guess the E3D tool changer, but the Exchange kind of also doesn't allow that, because the release mechanism with the magnet lever, you would also need to automate that somehow. But like something might
still be fine for putting a spindle on your sturdy 3D printer to do some basic routing or a laser attachment or something like that.
Absolutely.
I don't know what they have in mind. Do they have in mind that you put different hot ends on your machine, or do they have in mind that you use this tool changing plate for adding different capabilities to your motion platform?
So yeah, obviously these manual tool changes are not going to be for multicolor printing or multi-material printing. You're not going to manually change your tool every layer. But though it would be a fun experiment. So obviously, this is something I do want to bounce off of you. They are selling a one backplate, one mobile plate kit, as basically saying, okay, you can take your toolhead off of your printer and work on your toolhead separate from your printer. It's not having a backup spare toolhead. It's not being able to swap them. It's just you take this off and you do your thermistor swap or heat break fix or whatever you need to do. You do it outside of your printer. Is that something that you would see reasonable to spend $85 on? For adding this, and then of course having to print all the adapters and mounting your stuff to this new system, is that something you see as worthwhile?
What are you usually
That's
doing
not a yes.
when you're working on your hot end? unclogging a nozzle, changing a nozzle, if that's inconvenient on your machine. So with one plate, no, I don't think so. If you have like a second plate, I think it might be worthwhile if you, for example, regularly print like very flexible material or materials which might not work well together.
Yes, we'll get to that in a second. So let me just finish up the single plate offering for now, because my thinking is, okay, if you're putting this on just so you can service your toolhead more easily, like you're planning for failure, you're planning for the event that stuff fails. Like, why not spend those $85 and get yourself a Hemera? Well, you can't buy them, but that's a different story. Why not set yourself up for success and actually upgrade the components you put onto this instead of spending the money to be able to like fix the stuff you put on it?
That's the same discussion why people buy Ender 3s and spend like $300 on modifications and improvements, whereas they could just use that amount of money and buy something proper in the first place.
Yeah, well,
it goes in the same direction. It's not totally the same.
The thing is, other than the Prusa Mini, there's just not that much like in the affordable range. But like, okay, different story. So the other thing is, they have a kind of like the Exchange. They have a 1x3 kit, so one base plate, 3 mobile plates. And so it's $145 or $150 roughly. I need to look up the exact pricing. Same as the Exchange, basically. And applications are, okay, you can put like a volcano and a regular hot end. You can put an experimental toolhead where you have one that you know is good and you keep like in the shelf, and you know it's always going to be able to get you printing, and you use a separate one where you do, I don't know, weird nozzle stuff. We know we're all into weird nozzle stuff, but you do that on your one plate that you can experiment on, and you keep the other one ready. Or you have, I'm not sure if the designs for these plates are going to be like public. I'm going to need to ask Peter about that. But I've seen these mobile plates printed as just a passive plate with no electricity and just a marker mount, or a felt pen basically, that enables you to convert your 3D printer into a plotter. I've done that on printers in the past. It was a huge mess because you have to like modify stuff left and right, and you're messing up your printer basically. So that's a pretty, I think that's a legitimate application for being able to actually swap out toolheads, right? That's what it's all about.
But how are they handling? For example, if you would change from a normal extrusion head to a laser head, how are they? Do they also offer a solution that make the firmware changes that might be necessary? Nope. Okay, because if you just remove the thermistor,
printer's gonna freak out.
Yeah.
Nope. No. So the this thing is getting announced, I think, today or tomorrow or something. The Exchange guys do offer, I think, firmwares for some printers that are pre-configured for tool changing. Marlin does support tool changing, where it's like, okay, you select this tool and it loads, I think, presets for thermistors and stuff. I figure you would need to disable the safety features, the thermistor min temp, once you remove this and replace it with a plate that does not have a thermistor. Or you could just put a thermistor in the plate you're replacing this with. Like you measure the temperature of your felt pen. Just make sure you're not going too fast and make sure it's not burning up. That E-steps is, I mean, that there's no, I guess you could hook up some sort of a small EEPROM to the plate or something, but that's your challenge then. That's your problem to fix essentially. What this mutant plate or system is basically is just the mechanical and the electrical connection. Everything else is for you to figure out. Just a building block essentially.
Okay. Interesting.
Yeah. Very interesting. It's just it's nice to see these things, but this thing feels super rough. You can kind of see the on the stream. God, yeah, you can really see it. It's called what's it called? Sinkholes, sink pitting, sink something where you have, I don't know, maybe
too thick material.
I don't know how I can switch to my webcam view that you're seeing, but basically,
is the plate so solid that they have those shrinking areas?
Yeah, it's literally just a 5mm chunk of plastic.
Okay.
So this is solid, which also, I mean, is a good thing. It does have a mounting pattern in there, but if, for example, these don't line up with a Hemera, for example, but you can just drill your own. Like this is just solid carbon, not glass fiber reinforced nylon. You can drill your own holes anywhere. This is all just solid stuff. So it has its ups and downs. So yeah, if you've seen this episode, then you don't need to watch my video. Cool. But you know whose videos people are watching?
Oh yes, Mars Gizmo.
What else?
The biggest 3D printing YouTuber I didn't know about.
Damn it.
Bigger than Joel, bigger than Angus, bigger than RC Live On.
Yeah, combined.
And he
all of us together, that guy gets more views than all of us.
Views, yeah. So I'm not a TikTok guy yet, or I don't know. Mars Gizmo, I think, is one of the biggest 3D printing TikTokers with almost 1 million followers on there. And just a couple of days ago, I got a video in my recommendation feed about something 3D printed, and I've seen this guy again. He is on YouTube for 4 months, 5 months, couple of months, and he has already like 800,000 subscribers, doing 5 million views every day. This is just something. Well, we could basically dream of 5 million views is something I get in like 4 months, and he's doing that every day.
Why are we even bothering, man? Like, why are we making 10-minute long videos?
Yeah. Before we start with that, what Mars Gizmo is doing, so I think he is coming from TikTok. So he is posting like 30 seconds to 1 minute videos about things that he mostly, I think, printed from Thingiverse. I think the videos are well done. He nicely narrates them. So he also puts attributions in his descriptions and stuff like that. So that's totally fine. But printing like one of these alien scissor things and getting 10 million views on that and doing like a 40 seconds video on that, I would probably say I get a little bit jealous or envious.
It's not,
and ask myself why we are putting so much time and effort in researching and making videos if you could just do short time lapse videos of parts. And
you know why? Why? Because we suck at making videos. We suck at YouTube apparently.
We suck at social media, I'd say. I wouldn't say that we suck at YouTube. I would say we suck at social media and finding the newest trend and going on TikTok.
Yeah, but it's for me that's kind of a decision. Okay, do you completely hard switch to that style of video and make something new? It's like that would be a smart business decision. From a I want maximum revenue for the time I spend. It's I don't know how long I could do that. It's for me, I'm always factoring in okay,
you only have to do it for a year and you will earn more than you would now earn.
Okay, that's a good point. That's a good point. For me, it's always does making this sort of content make me happy and do I feel like I'm providing value? And I'm sure Mars Gizmo is providing value there as well. It's entertainment, and it's it's content that isn't for us millennials. It's Gen Z content, right? Attention span of like 21 seconds, which is his earlier videos. Now it's like 34, 42 seconds. that's all you can get out of them.
All in portrait format.
Oh yeah, exactly. And YouTube has greatly contributed to the success of this sort of content as well, where it's cheesy music. Accidentally clicked on one of the videos. Where on the YouTube homepage, it's got its own section of short videos. I don't know if it's visible on the desktop. I don't know on mobile. It's like there's regular video, then there's short videos, then there's regular video, then there's stories, and there's YouTube is pushing that quite hard, and I think he definitely caught the right moment where YouTube was starting to push that, and he was one of the first guys in that separate feed where only those short videos end up.
Though I'm not even sure if he released those videos as YouTube stories. I think he just posted them as regular videos.
Yeah, that's the thing about YouTube. They want to try to be everything. So YouTube has regular videos. YouTube has stories. Stories is completely separate. Stories go away after 7 days and all that. But apparently YouTube has a separate promotional feed. Let me see if I can find it on my YouTube app, where out of the regular videos it picks, I think, portrait format videos and videos that are there we go. Portrait format videos and videos that are less than a minute, I think, and shows it as a separate section. So I'm thinking you can see that.
Always,
oh god, now I've refreshed.
I thought those were always the YouTube stories.
Nope. So we've got regular video, we've got news, we've got a post, we've got stories where there's nothing. Then we've got an ad, and then we've got short videos. Yeah, short videos. Amazon Alexa Echo Show 5 under cabinet 3D printed holder. Who is that? Oh, it's Mars Gizmo. That's where he's getting the views from, basically. He basically gets his own section on YouTube, on the YouTube homepage. Who is this? It's Engineer Risley, and sometimes my phone does it where it can't decode H.264.
Okay.
But yeah, that's.
I would really be interested if you, who are listening at the moment, if you knew this guy and if you are regularly watching him, I would really be interested what the audience is. Yeah, you said Generation C, but I was totally unaware of that guy, and
TikTok's a different world, man. It's we're getting old. It's like my
social media manager,
preferably like a 14-year-old or something. Yeah, gotta keep up with the times.
If they're good, why not?
I mean, the question is because I didn't see an ad on that. YouTube stories are not monetized. YouTube stories are promoted to us YouTubers by YouTube basically as, hey, it's a way to reach your followers and to show them what you're working on and to gain subscribers. I don't know if these Kurze videos, these short videos, are actually making them any. Oh, it's even got the TikTok banner in there. I don't know if these are monetized in any way. So you might be getting millions of views, but like if there's no ads on it, you're not making a penny. Except YouTube Premium, maybe? I don't know. But
I don't know. Well, he's at least following me on Twitter. I'm quite sure he's also following you on Twitter. Ooh. So we should reach out to him and get him on the podcast.
Sure, let's reach out to the youngsters. Hello, fellow kids. Now, what's the meme? It's hello, fellow kids. Yeah,
we're still laughing, but like in 10 years, when my daughter's in that age, I either will be totally up to date then because she can tell me everything, or I will be like totally messed up.
The thing is also, like, in 10 years you're gonna have the next thing coming along. You know, we're generation YouTube. We managed to get our foot in the door there. You know, after us there's generation TikTok, and after that there's going to be generation I don't know what. Before us there was MySpace, and you know, for the people older than MySpace there's Facebook now. So like the question is like, is
generation SchülerVZ?
Oh yeah, StudiVZ, sure.
StudiVZ, you're probably too young for that.
Yeah, but the question that arises from that for me is like, should we pivot? Should we just say, okay, YouTube is dying, YouTube is killing, the platform? Should we dump that and just jump onto TikTok and just, capitalize on that and make sure we get our foot in the door there before, we burn ourselves out on YouTube and just try and fail making content there that actually reaches people?
But this is actually one of the questions that I had. So you can see it in one direction, that you only make content for those new platforms, or you use those different platforms to also promote your content that you have on YouTube, where like the full video is.
But does the TikTok audience care about videos that are 15 minutes long and go in depth?
This is the big question, because I think, yeah, as you said, the audience is probably different to the ones that are watching us at the moment. But at least if you have 1 million subscribers on TikTok, there is a significant percentage of people that are also interested in more educational and engineering materials. So why not also monetize on that, and maybe even inspires some of the kids to do something proper and not only watch like failed videos proper. I don't know. TikTok is wasn't it famous for dancing videos and stuff like that?
Yeah, because TikTok has a huge music library that is, I guess, licensed even. So stuff that would just get content ID to death on YouTube, you can upload on TikTok, no problem. The fact that he's saying something proper is like that's already implying that, doing TikTok and making internet content isn't something proper. Because I mean, we're doing YouTube stuff, right? Is that's something that wasn't considered a proper job for the longest time, and probably still isn't.
No, it's still not. If you talk to like basically
the boomers,
the boomers. I don't know.
It's
as I say, yeah, guys. Let me know if you watch that. If there are even others that are doing like,
but you're gonna
printing engineering things on that platform that are maybe even worth watching.
But you're gonna if you ask our viewers, our listeners, hey, do you listen or do you watch that sort of content? You're gonna know, because it's a different ecosystem. It's different bubbles.
Yes,
there's a TikTok bubble there.
But
you're trying to find the crossover.
Yes, and if there is already a big crossover between our listeners right here and this audience right there, I need to think about if I'm not up to date anymore, and if I definitely need a social media manager.
Yeah. What I've also seen is just if you have like project content, just an edited down version of 60 seconds. I think I Like to Make Stuff does that. That is shareable on Facebook or messenger platforms, where it's like, okay, I'm not going to spend 15 minutes watching the full video, but I'm going to get a teaser of a minute, and I'm still going to watch it. And if I want to learn more, then I can jump into the full video. Maybe that's something we can do on YouTube as well, where it's videos that show up in that feed but are a short version of what we're already doing. There's automatic
with
go ahead.
Life hacks and you're gonna be
the depths, the pits of what was I gonna say? I don't know. I don't actually know.
There is a feature to automatically...
Oh, yes. There's features to automatically reframe content for different aspect ratios in Resolve and in... I think it's Resolve 17 that's bringing that. And in Premiere as well.
Okay.
AI reframe, where it's... You can do the vertical content automatically, and it automatically crops in on the correct portions. Which would be ideal for that.
Yeah.
Oh, well. We're getting old.
All right. We are getting old, and I think we already are like 130, 140.
Yeah, 130.
Podcast.
So right timer.
Maybe just go shortly over the questions.
Yes. I'm looking through them, and it's basically Trim-A-Line. So
It's Trim-A-Line.
So that's your topic.
Yeah, Clint is asking regarding Trim-A-Line. Are the cellulose of POM filament responsible for the formaldehyde that it emits?
Sorry, that the kerning is weird on the M. It's like, well, is this POM filament or is it porn filament? Filament maker. There's an idea for you. No. Sorry.
To be totally honest, I have seen POM filaments from different manufacturers and also the BASF Ultrafuse, and I haven't read like a specific warning on there. Pay attention. Does emit harmful formaldehyde. Don't breathe it. So in that regard, I don't feel that bad anymore for myself, but I feel bad for like society as a whole. I think they should point it out because it's definitely a problem, and you shouldn't be printing POM in your college dorm room.
Oh yeah,
which
sure.
I'm quite sure people are doing.
Oh, Ultrafuse is POM based. 316
Ultrafuse, yeah, supposedly, I think it's using POM as a binder, as a primary binder, and then there is some other secondary binder that doesn't get released during the burn outs or where it gets to the brown state, and that leftover material is then burned out during sintering. So, and as I said, I did not see any warning on there. And they also, I think, don't specifically say in the material safety data sheet that it is POM, but POM is pretty common in the how's it called, the pellet material from BASF for MIM Catamold.
Okay, yeah.
Okay.
So checking, it's the MSDS is basically for storing and for handling the filament itself, but not for the printing process, which is kind of weird. Control.
So I'll probably like remodel my old office to my printing room, but since that printing room is still like in our house and not in the basement or in a shed outside, I'm really thinking about putting like a big ventilation system in there with a big charcoal filter from a grow shop and a H14 HEPA filter.
Yeah, so
just where all of the air is recirculated all of the time. Because I'm kind of, I wouldn't say I'm scared, but I want to make sure that I don't breathe too much of that stuff. And since I have a small daughter in my house now, I also don't want her to breathe that stuff. And since venting outside is always a problem with energy recuperation and all of that stuff, why not do it like the funny cigarette growers? And
I mean, I've got my ventilation system in here in the studio, which is not just energy, but what's it called? With humidity recovery, basically.
Yeah.
But it's also not 100% efficient. So you can feel the air coming in is significantly colder. So it does use a lot more energy or heating energy than if you just had a recirculating one. But of course, with recirculation, you kind of need to make sure that it's actually taking out the stuff that you're trying to get out. Yeah.
For this, ultra fine particles are probably really hard to get out, but I think a big industrial H14 HEPA filter and a really beefy charcoal filter should filter out most of the stuff. So, and since I'm usually only printing PLA, PETG, and some other stuff, it's definitely better than nothing, and it's definitely better than just venting my room every day just once, and all of the other time venting into our house.
Exactly. Yeah.
Maybe on the same mark, Jake. JPhone1 was asking regarding the risk of printing trimmer line. Isn't there even a health risk printing with ABS? You could probably make a disclaimer in front of every video because be careful, hot end is hot. It's difficult to draw a sharp line when a warning is necessary. And I think in this case, you made the right decision. Just as we said, yeah, basically printing anything is harmful in one way or another. Some are more unhealthy and more obvious because ABS stings, but also PLA and PTG are probably not healthy. So just always keep that in mind and don't print in your college dorm living room.
Yeah. The less air volume you have, like if you have a college dorm that's just 2 beds and 2 desks maybe, then that's going to fill up and just accumulate particles and VOCs and whatever else gets released much more quickly than if you have an industrial hangar where you print with a single PLA machine. So just keep that in mind.
3D Printing Llama is basically asking, do a second video and point out the risks, and also I think there was somebody else was also asking about researching that topic or testing that topic in a more thorough way, which materials are emitting whatever. I would really like to do that, but I think in order to do that properly, you need equipment that is horribly expensive and that I don't have, so I don't really want to burn my fingers in that direction because you can basically only go wrong.
So on the topic of actually measuring emissions, there are papers on that. There's been research done on not exactly, but on how much different types of filament emit. I don't have the means to reproduce that either. What you can measure relatively easily is just a VOC value, which isn't like an exact ppm or whatever. It's just a relative. Okay, this is twice as much ppm than what you calibrated against, and you can measure PM 2.5 and PM 10 particles very easily. In fact, just 2 days ago, I set up like they're called Airrohr, so air pipe. It's a community-driven project by the University from Stuttgart, I believe. You get the sensor, you get a Node MC, you put it in a box and you put it outside, and it continuously uploads and measures particle data. But to the point, like PM 2.5 and PM 10, really easy to measure. However, 3D printers don't really emit all that much when it comes to those rather large particles. Like 10 micrometers is a pretty chunky boy. What you kind of have to worry about is the UFPs, the ultrafine particles that are like 0.1 micrometer and below. And equipment to measure that is not that readily available. So like I said, I did try to measure if I was getting like any sort of tick on the reading, but it's like it's so insignificant, the amount in that size that you can measure. It's like you're not going to be able to find anything with the commonly available stuff.
You are able to. I have like a $150 VOC, PM 2.5, PM 10, and formaldehyde detector, and it is definitely changing when I print next to it. But
VOC is probably more than the particles.
And I think it also is different depending on the material. But on the other hand, how do you set up everything? What is emitting the particles? Are those the bearings? Are those the dust that covers your print bed and stuff like that? It gets horribly complicated.
Yeah.
So currently, I really want to stay away from that topic, even though it's interesting.
Yeah, it's one of those things. If you do it, you have to do it properly, and doing it properly is kind of out of reach. So, yeah.
Cool.
All right.
I think
we did it.
That concludes it for today. I'm totally messed up, and my wife is waiting for me to finish our Pax-Schrank that we received yesterday.
An
IKEA Pax-Schrank is a big project.
Yeah, I have one of those too. It took me like 2 days to fully assemble it, and I don't even have doors on it. Oh well. Okay. Well then, Stefan, thank you for taking the time. Thank you everyone for watching, listening, and joining us on this, overdue episode. If you want to support us, you can do so by subscribing to this channel, to subscribing to our YouTube channels, or through Patreon. And other than that, thank you, Stefan, for taking the time. Thank you all for watching.
Thank you for watching as well. Put your questions down below, and until next time.
Goodbye.
Bye.